Today's lesson, 1.6, day 1, is titled Solving Absolute Value Equations. So our objective is to write and solve equations involving absolute value. We need to talk about some properties before we continue with our lesson, okay? And so we have some different properties of absolute value. And they say let A and B be real numbers, meaning any number on the number line. Okay, so it could be positive or negative. It could be a whole number or a decimal or a fraction. But it has to be on our number line somewhere. Okay? So this first one says absolute value of A is greater than or equal to 0. An example of that would be if I had the absolute value of -5. Well, the absolute value by definition, two ways to do it. It's simply the distance that number is from 0. So if we think about -5 on the number line, how far away is it from 0? 5 spaces, right? And so the absolute value of -5 is actually +5. I don't know, do you guys remember absolute value? Is it ever negative? No, the absolute value is special that it always just creates this positive version of it. So whether it is a positive number, it'll stay that way. If it was a negative number, it'll change to positive, okay? So that's one example. Another example is if we had the absolute value of 0 itself. What's the absolute value of 0? 0. That's why for this property, it has that or it could be equal to 0. So it's not only just greater than 0, but it could equal 0 at times as well. It will never be a negative number though. That's important to note. On this next one, we have multiplication happening between a number A and B. And they said the absolute value of the multiplication of those two is equal to the absolute value of A times the absolute value of B. So it's like you can split it up, okay? So for example, if we had the absolute value of 4 times -3, that would be the same as if I had the absolute value of 4 times the absolute value of -3. They are equal to each other. So technically, this property says you can multiply first and then find their absolute value, or you can find their absolute value separately and then take those answers and multiply. Really, we'll see when it benefits us, we do a certain method with it. And that's why this property comes in handy, because I need to know, can I split it up? When can I split it up? The next one, absolute value of -A is equal to the absolute value of A. I was kind of covering our previous statement of, hey, absolute value is never negative. Okay, so when I have an absolute value of, say, -7, that is actually the same as having the absolute value of +7. They both are equal to 7, okay? So any negative version and positive version of a number, any opposite numbers, if I just take the absolute value on both sides, they're equal. The last one is division. And it says the absolute value of A divided by B is the same as the absolute value of A divided by the absolute value of B. B just can't be 0 in this case. Because everybody, try in your calculators right now, or actually we could even do it in person too. If we have, say we have 24 people in class, okay? I want you guys to make 0 groups. Can we make 0 groups? No. The smallest amount of group I can make is one single group of 25, or 24. Do 24 and try and divide it by 0 right now on your calculator. Is there an issue?
Error.
Error. Because you can't make 0 groups. If you have one whole group of people, you have one whole group. There's no way to make it a 0 group, okay? And that's why they're saying, hey, B can't be 0, because B is doing the dividing. You can never divide by 0, all right? So an example of this guy would be if we had the absolute value of 3/5, that could be equal to the absolute value of 3 divided by the absolute value of 5. And again, it's just saying you could divide first and then do absolute value, or you can take the absolute value of each one separate and then divide. It doesn't matter. They're both going to give you the same thing. So now that we kind of covered some properties of absolute value and reviewed that, let's move on. We're going to solve each equation, and we're going to graph the solutions. It says, if possible. Okay, if I have no solution, because remember we talked about equations sometimes don't have solutions, right? Sometimes they have one solution, sometimes they have infinitely many. If I have no solution, is there any way to graph it? No, I would just leave the graph blank, okay, if there is no solution. So here's how we do it. I'm going to zoom in here. Does everybody have the properties? Can I scooch it up a little bit? Okay, let's see. I'll leave those two going. So if we look at this, it says the absolute value of x minus 4 equals 6. Okay. There's something really important with absolute values because I cannot just solve it like any other equation. Normally, if I did not have these absolute value bars, what would you do first? We would add 4, right? These absolute values change what I have to do first, okay? So, inside here could be 6, or it could be negative 6. Because remember we talked about this property, the second to last one. We said, hey, the absolute value of a negative number is the same as the absolute value of a positive, okay? These absolute value bars right here around the x minus 4 tell me that that inside could be negative 6 because I haven't taken the absolute value yet. Or it could be positive 6 because, again, I haven't taken the absolute value yet. All right? Because I have those two options with absolute value, I have to solve two separate ways, okay? So anytime we have an absolute value equal to a positive number, because that's my second check, if this number is not positive, there's no way I can solve it, okay? So I have the absolute value by itself. I have a positive that's equal to. Yay! So now I need to create the two different forms. The inside is still x minus 4. That's not changing on either form, x minus 4, okay? Notice I dropped the absolute value piece at this point. I'm allowed to drop it at this point because I'm writing two separate equations to cover that, all right? Now, in one version, it could be equal to negative 6. In the other version, it could be equal to positive 6. By definition, this is absolute value. Inside could be a negative. Inside could be a positive. I don't know until I solve it. All right? So we're going to do both of them. Hence why I said the or right here in between. So now let's solve it. Now I don't have any absolute values. We can solve this like you guys were telling me. Add 4 to both sides. Now I have x equals negative 2 on that side. Or the other one, I'm going to do the same thing. Same step, still have plus 4. Do I get the same answer though? No. What do we get? 10. Okay? If we were to plug it back in, I'll do it off to the side here. You guys don't have to do it, but I just want to show you. Miss Heron's not making stuff up, I promise. Okay, if we plug in negative 2 for our x, okay, that was our first answer we got. What's negative 2 minus 4? Negative 6. What's the absolute value of negative 6? So this is true, right? Woohoo, okay? If I do positive 10, okay, everything else is the same, but now I have positive 10 minus 4. What do we get? 6. Is the absolute value of 6 still equal to 6? Yes, okay? So absolute values are special because the inside, when I'm talking inside, I'm talking about inside the brackets, could be a negative or a positive. What it equals can only come out positive, but what goes in could be either one, all right? So all we do to graph these guys, since we have two of them, we put a dot on negative 2 and a dot on 10. Where's my 10? There it is. Feel like, oh, okay, good. I was like, your 10, I don't think got hole punched, but maybe it did. Okay. And that's it. I just put a dot. There's nothing I have to put in between. There are two separate points. We're not connecting them at all. Okay? So then the next one. Let's look into the next. We have absolute value of 3x plus 1. All right, so my first thing I want to check is that the only thing on this side is an absolute value with stuff inside of it. There's nothing outside being multiplied or added, which is true. And then it says it equals negative 5. All right, well, is negative 5 positive or negative? Negative. By definition, Will an absolute value ever equal a negative? No. So as soon as I see that they're trying to tell me that the absolute value of something is equal to a negative, this is not true, and there is no solution. Okay? Which means, do I have anything to graph? No. If you want to cross it out, that's fine. If you just leave it blank, that's fine. If you want to write no graph, that's fine. On big ideas, I think it says only graph if you have an answer, so you just leave the graph blank in their case, okay? Next one, absolute value of 3x plus 12 equals 0. So I have 3x plus 12. There's nothing outside the absolute value bars. Everything's inside. And now it's equal to 0. Is that positive or negative? Neutral. All right. Neutral. It's 0. Can an absolute value equal 0? Yes. Okay, we can solve this. So we're going to do it just like we did with, almost like we did with the first one. Okay, so since 0 is not positive or negative, is there a negative version of 0? No. So in this case, remember how number 1, I had to set it equal to the negative version and the positive version? Well, there is no other version of 0. It's simply 0. So I get to take 3x plus 12 without the absolute values and just set it simply to 0. And then we can solve, as we've done in the past, minus 12 on both sides. 3x equals negative 12. Divide by 3. And x equals negative 4. Okay, I can quickly check that real fast. I'm just going to make sure we're good. Okay, absolute value bars go back in. I replace my x with negative 4. And so negative 4 times 3 gives me negative 12 plus 12. What's negative 12 plus 12? 0. And the absolute value of 0 is 0. So that's true. Awesome. So there's only one solution. That means I go to my one solution and I put a dot on it. My one solution is just negative 4. So find negative 4 on your graph and put a dot. So those were our 3 different types. Sometimes you'll get 2 separate numbers. Sometimes you'll get no number, right? No solution at all. And sometimes you'll just get one number. It depends. Positive will always give you 2 different numbers. A negative will always give you nothing, no numbers. And a 0, it being equal to 0, will only give you one answer, okay? Let's see. Ooh, look at this guy, okay? Absolute value of x equals 10. Well, absolute value is, nothing's outside the absolute values, right? So we're good there. What about the 10? Positive or negative? Positive. So, do we have answers? Yeah. I love it. There's not much to do here. Take your x, set it equal to negative 10. I have nothing to add or divide or anything. There's one answer. Or x is equal to a positive 10. Sometimes it is that straightforward where there's actually not much to calculate. Okay? What about number 5? None. Why? Good. As soon as you see that negative, that is no solution. Okay? And not only negative, but I see the negative, but also there is nothing outside those absolute value bars, right? If there's stuff outside, I do have to move those and make sure it still stays negative, okay? In this case, I had nothing outside the bars, and so, yep, absolute value cannot be negative. No solution, no graph. What about the next one? Oh, that one's an easy one. What's that one? Good. X equals negative 5. X equals positive 5. Again, nothing much there. Go put a dot on both positive 5 and negative 5. All right? So those were simple one step, and you notice all of these examples, 1 through 6, I had nothing on the outside of my absolute value bar. It was just the absolute value and stuff inside. Sometimes it had just x, sometimes it was multiplying, sometimes we had adding and subtracting. What we're going to do next, we have stuff on the outside. That creates one extra step for us, okay? Because I can't have something being multiplied out on the outside. I can't have something being added on the outside of those absolute value bars. I have to get them with only stuff on the inside, okay? So we are going to try that, all right? Our goal is still to isolate the absolute values, all right? Kind of like how we isolate our x. So anything on the outside has to get undone. We have to use that inverse operation. So on this first one, we have absolute value of 3x plus 9 minus 10 equals negative 4. This minus 10, I want a highlighter, sorry. That's on the outside. I have to undo that. What's the inverse of minus 10? Plus, yes, okay. And just like we've done for solving, keep that equal sign organized, and underneath, I'm going to add, I'll move my equal sign. Sorry, I'm going to add 10. Add 10 over on this side, okay? You have to keep the scale balanced with equations. On our left side, we have absolute value of 3x plus 9. I don't have to write plus 0. That 10 is gone, right? And now what's negative 4 plus 10? 6. Okay. Now we're at a good point. I only have absolute value with stuff inside. All right, so I have to see, is 6 positive or negative? Positive. So we do have answers, right? How many answers are we going to have? 2. Okay, let's split it up. All right, take this guy, and we're going to write 3x plus 9 is equal to negative 6. And then the other version, 3x plus 9 equals positive 6. I want to highlight here. This is the only difference between these two equations. Equals negative 6 equals positive 6. That is the only difference. Everything else is exactly the same. So now we solve it. What do we have to move first? 9, good. Subtract your 9, keep everything structured in order. Bring down your equal sign. And what do we have? Negative 15 there. Okay. And then divide by 3, good. And you get negative 5. Awesome. All right. Other side, so that's or, right? That's one answer. Okay. 3x plus 9 equals 6. So that first step is exactly the same, correct? Subtract 9. Here's where it gets different, though. I still have 3x equals, but it does not equal 15 or negative 15, right? What does 6 minus 9 equal? Negative 3, okay? I'm highlighting that piece because a lot of people just try and throw different signs but keep the same numbers. The numbers won't be the same. It's not just a sign change. It's a whole calculation change, okay? So now we divide it by 3, right? And what does x equal? Negative 1. Okay, they're not asking me to graph this time. Now they're asking me to check, which I kind of went through pretty quick on the first one because our main thing was to graph it second. So we'll do a little bit more step by step. If I have 2 answers, how many checks should I have? 2, okay? So whether you want to divide your paper, horizontally or divide it vertically, I don't care. Just keep track of which one you're doing first. I'm going to do x equal to negative 5. So to keep track, I just write it above so I can remind myself, okay, I'm plugging in negative 5 for x. So on here, we have absolute value of 3 times negative 5 plus 9, close it, minus 10 equals negative 4. I have to go back to my original, not anything that was altered, okay? So my original one is written. I replaced my x with the negative 5. Now we can do some calculations. Inside the absolute value has to get, it's like a set of parentheses almost, okay? I have to do that calculation inside first. So multiply 3 and negative 5. What do you guys get? Negative 15, and then add 9 to that. What do we get? What's negative 15 plus 9? Negative 6, good. And I still have the absolute value bars around it, right? So my next step, I can't subtract that 10 yet. I have to do the absolute value of negative 6. What's that? Positive 6. Good. 6 minus 10. Is that equal to negative 4? Is that a true statement? Yeah, so that one works out. Awesome. Okay. Yay. we have to check x equals -1. Same process, but instead of a -5, I'm replacing my x with -1 in there. Everything else is staying exactly the same. What's 3 times -1? Oops. Okay, what is -3 plus 9? Oh, are we off? 6. Okay. I don't think we're off. Good. Absolute value of 6 is 6. And 6 minus 10, is that still -4? Yes. Okay. We want to test both. Here's why. Later on, sometimes we get solutions that look like they're answers, but when we check them out, they actually fail. And so there's actually only one true answer. All right. I want to skip 8 for now. Let's go to number 9, because we have slightly different something outside, right? Okay. Number 9, it says 4. And what would I say? Do I just write 4 absolute value, or how would I say that? 4 what? 4 times the absolute value, 2x plus 7 equals 16. Since we are multiplying that 4 on the outside, can I have it there? Can it stay there? No. How do I undo multiplying? Divide. So divide it by 4. Divide it by 4. What happens is 4 divided by 4 is really just, it becomes 1. And 1 times anything, does 1 change it when we multiply 1 by a number? No. All right, so we're left with absolute value of 2x plus 7 equals, what's 16? Good. 16 divided by 4 is 4. Okay, now we have the absolute value with just stuff inside and nothing outside. And is it equal to a positive or a negative? Positive. So how many answers are we going to have? 2. Okay. One option, 2x plus 7 equals what? -4. And then the other option, 2x plus 7 equals +4. Good. Okay. Those are 2 possible solutions. What's the very first step for both of them? Subtract 7. Okay. -7 minus 7. Remember, keep your equal sign in line. 2x equals -11. Okay. I'm just going to finish this guy. What do we have to do to finish that one off? Divide by 2. Good. And that's not a bad decimal, so give me the decimal version. -5.5. Awesome. Okay. There's one answer. Or let's go to the other one. You guys told me -7 was that first step as well, right? But does it give us the same number? No. Why doesn't it? Because it's a +4, not a -4. So what's 4 minus 7? -3. Good. Then are we still dividing by 2? Yeah. Okay. And so x equals -1.5. Awesome. We got 2 answers to check. So let's check. I always check the first one first. Just keep in order. So we have 4 times the absolute value of 2 times -5.5 plus 7. Close the absolute value, and it should equal 16. So let's see. Inside, I have multiplication and addition. So I have to multiply first, right? 2 times -5.5, -11. Add 7 to that. What do we get? It's going to be positive. No, it's going to be negative. What's -11 plus 7? Negative, no, not 3, -4. Good. I can't multiply it yet. I have to do the absolute value of it. Okay, let's shut that for now. What's the absolute value of -4? +4. Good. Equals 16. Just close it. Okay. Does it work? 4 times 4, is that 16? Yes. Good. What about the next one? 4 times the absolute value of 2 times -1.5 plus 7 equals 16. 2 times -1.5. We get What do we get? You can do it in your head or on your calculator, either one. What's 2 times negative 1.5? 3, yeah, negative 3. What's negative 3 plus 7? 4. All right. Absolute value of 4 is? 4. Good. So both work out. Okay. Number 10. What do we have on the outside that we need to move? Good. We have a negative 3 or a minus 3. What else? Good. Which one do we have to move first? Good. All right. You guys do this one and the one before, number 8, on your own, okay? You could work with a neighbor if you need help, and then we'll check them together.